Precalculus, mid-first 6 weeks exam. We're going to start out with this one, problem 3, and one test is problem 1 for the algebraic expression 4n squared minus 9. Which technique would be the best for factoring? What's the greatest common factor? Well, we don't have any common factors between these two terms here, 4n cubed, 4n squared, and negative 9. So that wouldn't be right. Now, for difference of squares, it so happens that we can take the square root of both of these and we'll have on one side, we can factor it using a difference of squares, and that would be quantity 2n, which is the square root of 4n squared, plus 3, which is the square root of 9, times quantity 2n, minus 3, which is the square root of 9. So this is factoring using a difference of squares, so that would be our correct answer. Okay, we're going to go on to the next problem. How many discontinuities can be found in the following function? Well, we have, if we really know what we're doing, we can spot them right here. How many values of x are there that would make this denominator equal 0? Well, clearly, if we have x equals 0, that would be one of our discontinuities. If we have x equals 2, that would be another. Or if we have x equals negative 3, one thing we can do in a situation like this is graph. And when we use our calculator, we go to add graphs, and we have a graph here. And I don't know how, if you could see this, but we can, in the video, but if we enter in our numerator x squared, and in the denominator we have x times quantity x minus 2 times quantity x plus 3 . I don't know how well it's going to turn out in the video, but we will see. But we graph it, and we see a couple of discontinuities right here. And if we really want to see them for sure, we can go to see even our removable discontinuities by pressing Control T, and we see in our table view that we have a discontinuity at negative 2, or at 0, at positive 2, and if we scroll up, we should be able to see another discontinuity at negative 3. So we have 3 discontinuities. So let's go on to the next problem. For the function fx equals x to the 4th minus 7x squared plus 6x, what are the approximate coordinates of one of the local minima? So for this, we're going to go to our calculator again, and I'm going to go to Control I and get a new graph page. And here we have, we're going to put in x to the 4th. Here we have x to the power of 4 minus 7x squared. I thought this problem was quite a hard problem on this review. Plus 6x. And when we graph it, this is what we're going to get. We get this kind of operation here. So you're going to have two local, for local minima, you're going to have two. You're going to have one way down here below the view screen of the graph. You're going to have another little one right up here. So if we go to we can see the different coordinate values here and see which ones had a chance of being a local minima. Well, we can go to a trace view, and if we go to menu and we go down to 5, option 5, oops, let's go here, option 5, trace graph, and here we go, and we have our cursor right here. We can go to the, and just arrow over maximum, and it shows a minimum here, and we have a minimum that shows at 1.6 comma negative 1.77, and so that's going to be closest to answer A. He had a tough problem. We had a lot of people miss it, but with good reason. That's kind of a toughie. Okay, this one here had a lot of people had trouble with this one. I'm going to change my pen color on this one. Okay, let's see here. All right. Over what interval is the function decreasing? Well, here we have it increasing from negative infinity. That arrow is increasing, and then it's going to top off around here someplace at 1 or 2, somewhere in there. And from this point forward, I'll put it about right here, it's going to be decreasing. And so it's going to be decreasing all the way down. If we just go down to here, it decreases about here, and then to about there, then it starts up again. And so if we had to draw this on a number line, we would say it is decreasing from this point, I'm just using the x-axis number line, down to this point, so it will be decreasing over this interval. And that would be the interval between approximately 2 and 7. I can't tell you how many people chose decreasing between negative 5. Okay, the negative 5 is down here, it's an x-intercept, but that's not right. Okay, it can't be that. It's increasing, so D is our correct answer. A lot of people got that wrong. Can't get an easy problem like that wrong. All right, we're going to go to problem 6. Which graph shows a piecewise function? Well, this is just an either you know it or you don't type deal. Well, piecewise function is a function that has different function rules for different domain values, and the one we can see that really kind of changes the rules pretty abruptly and suddenly is this one here. All of a sudden you're going up to about a domain value of 1.5, 1.5, and it goes straight up, and then use this other type of function rule. So our answer is going to be B. Number 7, which is the fully factored form of the expression 3x cubed plus 24x squared plus 45x? Well, we use our different types of techniques, and what we do is we try to find the greatest common factor. Well, we know 3 is the greatest common factor of the numbers because that's divisible by 3, 24 divisible by 3, 45. But we have x cubed, x squared, and x, which are divisible, common factor having x. So we can factor out 3x from this expression, and we have remaining, 3x, let's put it like that, times quantity x squared plus 8x, 24 divided by 5 by 3 is 8, plus we have, that's going to be 15. And so really between these two, you're going to have 3x factored out. That already gives you a heads up on what can be fully factored, A and C eliminated. And then this quadratic trinomial we can further factor. I'll put the 3x in front of it. And we have quantity x plus something times quantity x plus something, because we have all positive numbers here. And based on the quantity x plus something, it can only be, b has to be eliminated. And we have x plus 5, that's quantity x plus 3. And that's going to work out. 5 times x is 5x. 3 times x is 3x. That's 8x. Works out great. Nobody should have got that one wrong. Number 8, find the values that are excluded from the domain of the function. Now again, clearly to find which values are excluded, all we have to do is look at our denominator. If we can figure out, solve this for 0, we can find the excluded values. So setting 4x squared plus 8x equal to 0, and again this is solving for x, but it's not for what x can be, it's for what x cannot be. And so we can factor, and our greatest common factor, if we have between 4 and 8, well, it's going to be 4, and between x squared and x, it's going to be x. So we know that if we multiply 4x times x plus quantity x plus 2, then we have our factored form, and we can set each one equal to 0. So if we set 4x equal to 0, we have 4x equals 0, and solving for x, we can say x equals 0. Divide both sides by 4, and so based on that alone, I guess we can cross off c. That cannot be right. And then we have our other factor, which is going to be x plus 2. Set it equal to 0. And if we solve for x by subtracting 2, then 2 minus 2 cancel to equal 0. We have x equals -2, and again, it's not what x equals, but rather, as I cross through the equal sign, what it cannot equal. And so we have 0 and -2, which is going to be right here. One way you could do it is if you went and graphed it in the graphing calculator, you could find your discontinuities in the by seeing the graph and the table view, and certainly you could find out the discontinuities there. Excluded values. All right, we'll go on to 9. What is the domain of the function interval notation? And you have this square root of x, quantity x minus 6 in the numerator, and x squared minus 16 in the denominator. Well, really we have two different excluded domain situations, one in the numerator, one in the denominator. We'll see where we are. If we take the denominator and set it equal to 0, we can break it up by difference of squares factoring to quantity x plus 4 times quantity x minus 4, and that would equal 0, which means that neither one could equal 0. So if we set x plus 4 equals 0, we clearly could solve that. So x equals -4, which means again that it cannot equal -4. And likewise for this one up here, x minus 4, we're going to see that x also cannot equal 4. So I put that does not equal 4. So there we have two discontinuities based on the denominator alone. Now looking at the numerator, we have x minus 6, square root of x minus 6. So we know that x minus 6 has to be greater than or equal to 0. So if we write x minus 6 is greater than or equal to 0, we add 6 to both sides of the inequality. I was going to say equation. It's actually inequality. So x is greater than or equal to 6. So what we have here is the function as a whole has to be greater than or equal to 6. So what that means is what these discontinuities are less than 6 doesn't matter, because they don't make a hill of bean of difference, because they just don't count. This is what really counts, greater than or equal to 6, and so we circle that. Now if you use your graphing calculator and put them in your graphing calculator, you would have seen an error, or an error for anything less than 6 in your integers. Well, we can quickly do that. If we go to graph, we'll go to tab, and we'll go up here and back up over this last one we did. And from here, we're going to go to our menu. Oops, wrong one, escape. I want to go to this key right here, and we have a fraction as the first one, and in our upper fraction we're going to put the square root, which is going to be control that, and we're going to put x minus 6 in the numerator under the square root sign, and then we go down here and we're going to put x squared minus 16, and I don't see that. Let me go to tab again. X squared minus 16, and what I see over here is right on the, you see right on the x-axis from 6 going to the right with that red line segment. Let's go to the table view. If we go to Control T and see what we see there, and we see here at 0 error, 1 error, 2, 3, 4, 5, and at 6 we see 0, and then at 7.03 and so on. And so what we have is that we see indeed, using the table view, that this answer A is our correct answer. So let's go on here to our next problem, 10. What value is restricted from the domain of the following function? Well, again, the function is undefined where x equals 0, because that would make this denominator 0, and that should have been quite an easy problem. Number 11, what is the quotient of the quadratic trinomial x squared minus 3x minus 70 divided by the binomial x minus 10? Well, there are a lot of ways we could go about this. We could use long division, synthetic division, and either one of those would give us a correct answer. But one thing that works really well, if you're not too well initiated with division, is if you take this and multiply it by these binomial factors, you find out which one of these binomial factors gives you this quadratic trinomial x squared minus 3x minus 70. So for instance, if I went to try answer A, and I'll just go ahead and multiply these together using a box method, set up a little box, and what we have here is x minus 10, so that's quantity x minus 7, and for this one we get positive 70 here, and we really need negative 70, so we know that that one is not going to work, so A cannot work. But if we try x minus 10 times x plus 7, we'll get a negative 70 right here. I'm going to go ahead and erase this and put in a negative 70. So that looks better already. And then this would be negative 10x. And this would be plus 7x. And combining like terms between these two, we're going to have negative 3x. So this one checks out. So definitely our correct answer would be D. And yes, it's set up here for long division. You can divide it out, and so, but we won't take time to go into that now. Now, what is the domain of the following function? G of x equals 1 over x plus 5 over x minus 3. And we can find our discontinuities here. We know if x equals 0, that's a discontinuity. And also x equals 3 is a discontinuity, because if x is 3, then this would make this over here on the right undefined. So on a number line, we would say that at 0 and 3, we would have our excluded values. And so we would represent our excluded values by putting a little open circle here. And then everything to the left of that would be, of that 0 would be part of the domain. Everything between 0 and 3 would be part of the domain. And everything to the right of 3 would be part of the domain. And so what that does is it's just represented here. We've got negative infinity, 0, union 0 to 3, and then union 3 to infinity, less than infinity. So D is our correct answer. Again, we could have graphed, got some help there as well. Let's go on to problem 13. What is the greatest common factor of the cubic trinomial 10x cubed minus 20x squared plus 35x? Well, the greatest common factor of all these numbers, it's not going to be 10, because 10 works with these first two terms and not with 35. So there's going to be a 5 in there, no doubt about it. So 10 is not going to be right. It's going to be 5x, or 5x squared. Well, the problem with 5x squared works for these first two terms, but not for the last term. So the only term that would be a common factor there of the x's would be that x. So the greatest common factor is going to be 5x. 14. What are the binomial factors of the quadratic trinomial 12y squared minus y minus 20? Now we can come down here and try our different answers. If we try answer C, we can take quantity 3y plus 4 times quantity 4y minus 5, and if we multiply them out, we're going to have over here 12y squared in the upper left. We're going to have plus 16y here in the upper right, because 4 times 4y is 16y, and here we have 3y times negative 5, so we'll have negative 15y here in the lower left, and in the lower right we're going to have 4 times negative 5 for negative 20. And so there and if we add these together, 16y minus 15y, we're going to get positive y, but we need a negative y. So what's going to happen if we instead work answer, so C is not going to be right. If we go ahead and work out answer D, and here I've starred it, we can have negative 16y in the upper right and positive 15y in the lower left, and these two terms here added together are going to equal negative y, which is what we had up here. So that being the case, D is going to be our correct answer. On the next one, 16. What is the domain of the following function? And please record your answer in interval notation. Okay, no multiple choices. Again, we have to have this under the square root symbol be greater than or equal to 0. So if we go ahead and put in 5 is 5 minus x is greater than or equal to 0, that will help us get it right. And really, to solve for x, we can subtract 5 from both sides of the equation. I would really like to add x because I can just get a positive x on that right side quite easily without having to divide by a negative number, because I'd have to change the direction of the sign. So what we have is 5 is greater than or equal to x, which, because of the symmetric property of algebra, we can make that x is less than or equal to 5. And what that means for notation is less than or equal to is going to be a bracket facing leftward, so it's going to be 5, and since it's less than, it's going to go all the way to be greater than negative infinity. So a totally correct answer would be, an interval notation would be like this: parentheses on the left, negative infinity, comma, 5, bracket, inward facing bracket on the right. And I took credit off for partial misses on that. We go on to problem 17. What is the discontinuity of the following function? And I had a lot of different ways of answering. A lot of you got it right. Most of you, I hope, I think, some of you just put down -3. Well, -3 is, I guess that's an answer, but you really want to have it in set notation or some other kind of notation. You could say for discontinuity, you could say, you could describe x cannot equal -3, meaning that's a discontinuity, undefined point. Or I'd like it sometimes in set notation. If you put down inside of a bracket -3, so you can write out verbally, x cannot be, or there is a discontinuity at x equals -3. Let's go on to 18. What are the factors of the trinomial x squared plus 9x plus 18? Again, you're looking for factors numbers which multiplied together equal 18, but added together equal 9. So if we factor using the box method, we can set up a box, and if we set up a box, we can put our x squared term in the upper left, which will be x squared, and we know the factors of that are going to be x and x. So that will be, if we put it right below our quadratic trinomial, we'll just go put x and x right here. And then we know that 18 is going to go right here, and we're going to try to figure out the list of factors. Now, one thing we know is, do we have any negative numbers here anywhere? No, we don't. So we can just put our negative numbers. So a list of factors of 18 will be 1 times 18. We'll put 1.18, 2.9, and 3.6. And those are the only ones I can think of right now. And if we put right next to it sum of factors, I'll put SOF for sum of factors. We have 1 plus 18 equals 19. We have 2 plus 9 equals 11. We have 3 plus 6 equals 9. And where do we find the 9 that we're looking for? Well, we're going to find it way down here. And that means that our factors are going to be a quantity x plus 6 times quantity x plus 3. And we can check it out in the box, plus 3x here. Oops, I put 3 in front of it. And then we have 6x here. And these added together, 3x plus 6x, are 9x. So our answer is going to be quantity x plus 6 times quantity x plus 3. And this would be our fully factored form. and we can box in our answer as correct. And one thing about the box method that's pretty good is that you're really checking it using the box method as you go. All right, number 19. How many discontinuities are found in the following rational function? Well, if you know this is a factorable quadratic trinomial, you would know the answer already. But if you haven't factored it, you could simply go to take your calculator out, and I'm going to move the calculator over here to the left so we can take a better look at it. And we'll go Control I, add a graph, and we go and set this up. We have x, and in the numerator and the denominator we have x squared minus 3x minus 10, and we have that. We can graph it, and we see two discontinuities here. And what do our answer choices show? Well, there are none, right? It's just asking. There are no answer choices. So we got to find out how many are. Based on what we see here, we see the vertical asymptote here at x equals about -2, and also about here at 1, 2, 3, 4, and about x equals 5. So -2, 5, but we can tell for sure by going to our table view by Control T, and we're just going to look up and down for undefineds, and at 5 we see an undefined, just like our graph showed, and at 2, and we can scroll up and down. As far as examining the whole numbers there, we would have to say that the answer is that there are 2. And I saw some of you wrote down there are 2 discontinuities. Then on the grid provided, sketch as accurately as possible the following function. Well, if you graphed it, you could remove it. You would get a parabola that comes down to about here and starts at -4, and then on the left will go up. And I saw a lot of sketch drawings, but I saw very few reasonably accurately made drawings in this. So I want to see in the future better attention to accuracy in the drawing. So that's the left side of the parabola, and the right side is over here. And again, I'm using my smart software, not as accurate. Now, if you graphed it, you would see let's go back to Control I again, and we're going to add graph. And if we go to tab is already there, let's put our fraction here, and we have x cubed, x to the power of 3. Oh, I got that wrong. And we have x to the power of 3 there. I got it right. Go over here, minus 4x. And then down in the denominator we press x, and we graph it, and when we graph it we see just like it is here. Now, a lot of you made the mistake of just sketching this graph here, but if you go to the table view, Control T, you will see a discontinuity. It's going to be a removable or point discontinuity at x equals 0. So in drawing it, we have to draw an open circle to represent that that's not part of the domain, and then we're going to just come down here, and it just goes to this open circle here, and the right comes up, goes through here, and the parabola. We'll arrow that way, arrow that way. Now this is a pretty rough sketch, but most sketches I saw were even rougher. So for full credit, we needed to have this open circle down here. And then for the AP, pre-AP class, they had a couple additional questions. Which of the following classes function will contain no discontinuities from negative infinity to infinity? Well, a logarithmic function it starts here at greater than 0, so its discontinuity is not strictly a discontinuity, it's continuous, but not from negative infinity on. Your rational functions can have discontinuities depending on what they are. Most of them are discontinuous. A square root function, remember square root functions, if you have y equals square root of x, it'll start here at the origin and go over like this, to the right and over. So it would not be that, but a quadratic function can have any real number as input value. So B is our correct answer. 22, I'm not even going to bother with that. It's just sketching it out and what a reciprocal or inverse variation function looks like essentially when it's done. So I'm going to stop there. I hope this test review has been helpful. When you go through the problems and you find these little blue numbers, there were two versions of the test. If it wasn't 19 on your test, most likely this problem or a problem very much like it was problem number 5. So that's the index. I hope this has been helpful. Thanks for viewing.